Am I audible? Oh, good evening, everyone. I'm Shafali Agarwal. I'm a PMRF research scholar at IIT Madras. So, this is our seventh TA session on the topic of basic construction material. So, mainly in this week, you might have studied about the different metals and how metals are useful in our construction industries. So, if we go to the outline of week 7, in week 7, you might have studied about what is iron and what are the different products of iron, how iron we get raw iron as a iron ore and how it is generated, and then what are the different type of steel reinforcing bars which are used in concrete structures. Mainly we will study about uncoated, coated, pre-stressing, and what are the different test methods to test our different rebars. And last is the structure steel. So by this week, you might have studied only about the uncoated steels. So we will just have a quick overview of this week. So first thing is how we extract or get iron. We are using iron ore, which is used to manufacture iron. So if we see this graph, India have almost 5% total world's iron ores. Almost 5% of iron ores are in India. And so the main function how we get from iron ore to, sorry, from iron ore to iron, how we are using, we are generally heating it up using blast furnace. So this is a typical blast furnace which is used to convert our iron ore to normal iron. So and if we see our uh, cross-sectional area of our main blast furnace. So we are adding iron ore, coke, and limestone. Those are the raw materials to generate iron. And then its blast furnace is heated at different temperatures. So it start at from low temperature of 250 degrees Celsius and it goes up to 1500 degrees Celsius. And at different stages, different type of reactions are happening. So if we see at 700 degrees Celsius, what is happening? Iron ore is reducing to iron. If this is iron ore, it is reducing to iron with combination of uh, carbon monoxide. And then at more higher temperature, limestone will decompose and then CO2 will react with coke, and so all these processes will take place, and like at last we will get the iron in the form of molten iron. So when we are getting our molten iron, then what we are doing, this is being, so if this molten iron is coming from the blast furnace, normally normal blast furnace, then this is being a molds will be prepared. Different type of molds are prepared in which we are adding this molten uh, iron, and the normal iron is prepared from it. So first type of iron which we get from in blast furnace is pig iron. So this is the basic type of iron which is directly we are getting from the iron ore and just heated it up, and then we are getting pig iron. So this type of iron will have a lot of impurities present in it. So, and other thing is it is not of very high quality. Its strength value is very low as compared to the other type of iron which are being processed from like pig iron or from the basic iron. So the next type of iron is cast iron. So in cast iron, what we are doing, if you can see, we are using sand. If the sand is filled in this mold, and then in this mold, sand is filled and some shape is created inside. Imagine a circular shape is created, and then this molten iron is poured into it and is like we are getting the iron from this type of mold. So that is a cast iron. So in if we see in construction industry where we are using this cast iron, mainly for the sewer pipes, or if for pipelines and all. And other thing is just sorry. So if we talk about cast iron itself, there are two type of cast iron we are talking about: gray cast iron and ductile cast iron. If you can see the difference between these two type of cast iron is the microstructure properties. The microstructure of normal gray cast iron is in this form, some lines and all are forming, and whereas in terms of ductile cast iron we have different uh, uh, we say impurities present in the form of this circulars or in form of some point defects. Okay, so based on the carbon equivalent, you can see the different properties of the uh, gray cast iron and gray cast iron, sorry. So if we see UTS, from UTS we will get the strength. So tensile strength properties of our cast iron as compared to the carbon content. So if this is the cooling condition, how the molten iron is cooled down. So based on that, our tensile strength will vary according to the type of cooling we are using. So in this case, you can see if we are doing chill type of cooling, sudden cooling, then our strength will be very high as compared if we are using some insulation or some sand. Like in this case, we are using sand. So in this case, our tensile strength will be low as compared to when we are doing the chill cooling. So other type of iron which we get from our iron ore is wrought iron. So this is the type of microstructure we have for wrought iron. What is happening here in this case? We are getting different grains. So we have grains and grain boundaries. And if you see the cast iron, so cast iron structure, microstructure is like a fibrous microstructure. It doesn't have proper grains or grain boundaries are forming. Whereas in case of wrought iron, a proper grain boundaries are formed and we have differently oriented crystals in different grains. So where actually this type of iron has been used is like in the monuments, Eiffel Tower, in this Statue of Liberty. What in these type of structure we are using wrought iron, and one advantage of this type of iron is it is very lightweight. So if you have seen in your homes and all the railings and all, they are made from the wrought iron. So in case of cast iron, we have how much amount of carbon content normally? Normally, we have 3% of carbon content in case of cast iron. But in case of wrought iron, we have less than 1% of carbon, and also along with carbon, we have some slag inclusions. So this is another type of iron. So if we see, we have three iron we talk about: cast iron, ductile iron, and wrought iron. So these are the different microstructure of these three type of irons. And you can see particular grains are formed in this wrought iron, whereas in cast iron and ductile iron, there are inclusions or some globules forming of the different impurities. So this is another curve. This is a stress strain curve for different type of iron. So if we talk about pure iron, as we say the pig iron, where we are not adding anything else, in that case our strength is very low. And if we increase the iron content, if we have almost 1% iron content along with some slag, that is wrought iron, our strength is increasing. Same way, if we have mild steel have normally 3 to 6 percentage of iron. In that case, our strength is increasing more, which is And lastly, high carbon steel. High carbon steel is the type of alloy. It can be anything, stainless steel or anything, which have high content of carbon. It will have more tensile strength as compared to the other type of irons. Okay. So, as we have talked about from iron ore, we are taking our iron to blast furnace. From there, we are getting molten metal. So this molten metal is taken to different type of molds, and we are getting the different iron products. So what type of manufacturing process can happen in at this stages? We can have after taking it from here, after we can have it in terms of different slab kind of thing. If we are doing hot rolling, so it can be bloom slab or anything. Otherwise, if we are doing cold rolling, we can do section milling, wire rod milling, plate milling. So it is if we see our normal rebars, construction rebar, they are in circular shape, right? So what we are telling is it is normally milled in that kind of shape. It is milled and rolled and milled in that shape, and then we are getting the main products from it. So these are the different procedure. I don't you don't need to know all this procedure. Other thing is what is happening once we have prepared our iron. We have our iron, or in our case, we are telling we have our steel with us. Now, what is happening in case if it is exposed to oxygen and moisture? If ex moisture and oxygen are there, if these two elements are there, there are chances that our iron, pure iron, will convert back to iron oxide. So iron can oxidize to iron oxide. Okay. That is a general thing which we are seeing in our normal iron materials, like we will call it as rusting of iron. So normal, if you are keeping any iron piece open in environment, there are rust will be forming up around it. That is in the presence of moisture and oxygen. So even if one element is absent, then rust won't form properly. So, however, that is not possible naturally. And other thing is, in case we have, what are the causes of corrosion? So this is what is causing the oxidation. And next is what is causing the corrosion. So what is the difference between rust formation and corrosion is, rust is means directly iron is converting into some oxide products. However, when these oxide products are being like, if Fe2O3 will further oxidize and form FeOOH. So these are like uh, these rust products are highly voluminous and will cause deterioration of material. So that is called as corrosion. So in our case, in structure case, whenever there is a presence of chlorides near a steel bars, what will happen? This iron will react with chloride, sorry, ions will react with chlorides and it will form ferric chloride. So this will create a pit in a normal rebar. So that is a one, what will say, cause of corrosion. Another cause of corrosion is, in our cases, carbonation. So this is not carbonation, this is actually salination only. So in case of freezing areas, mainly if you see in hilly areas, when there is too much ice on the tracks or on the roads, they will actually pour the salt water over it. So what will happen? Salt water will melt the ice. However, when the salt water will penetrate through the concrete and go to the rebar, again there is a chances of corrosion. So other thing which is causing corrosion in our steel rebar is carbonation. So what is happening in case of carbonation is when carbonation will take place, the hydroxides in our concrete will reduce. So the pH level of concrete will reduce to 9 to 10. So if pH is reducing, our strong oxide film which is formed around the rebar, it will deteriorate and it will cause corrosion. So I think you will read about these things or might have already read. So other thing is, what are the different type of, firstly, what are the different grade of rebars which are available in India? If you see from this diagram, so usually we have Fe250, which we call as mild steel. Then we have high yield strength deformed bars. So HYSD bars, mainly which we are using nowadays in India, 415, 500 and 550 actually. So these are the rebars which are usually used on the site. And if you talk about grade, so what this 550, 415, 250 represent? It represent the characteristic strength of the rebar. So these are the different grades of rebar which are available in India. Other thing is, what are the different type of reinforcing bar? So first we talk about iron, how we are getting iron from the iron ore, and then what are the different type of iron? Three type of iron we talk about. Which one were those? Wrought iron, ductile iron, and cast iron. So next thing is, if we come to our structure parts in construction part, then we have different type of reinforcing bar. Now we have normal plain rebar. Then we have cold formed rebars. Then we have normal TMT rebars. These both are TMT rebars. Then we have coated rebars. So these are our coated rebars. This is coated with galvanized. These are, sorry, zinc. This is coated with the epoxy. This is another type of epoxy. And this is a type of as a corrosion resistant rebar. This is some metallic coating again. And next is pre-stressing strand. So pre-stressing strand, and last is fiber reinforced rebars. So these are not made of iron or not made of metal. These are made of the fibers. So first is the plain rebar. So plain rebar, we all know, cast iron normal rebar, that is a plain rebar. Other thing is ribbed rebars. So this ribbed rebars, which we are actually using on site, you all might have already seen these kind of rebars. Why we are providing ribs along the rebar? Is to have a good bond between concrete and reinforcement. So next thing is cold twisted deformed bar. So what is happening in cold twisted deformed bar is, if we are increasing the amount of cold work, we are increasing the strength value. However, the ductility of our material will decrease. So in this case, we are not heating it up. We are just that's why it is called cold twisted deformed bar. So there is no addition of heating to it. It's just, let's say, annealing. So what is happening? If you see from the grain structure, when you are twisting your rebar, the grains will expand, and this is how it will look like. The grain structure will look like in this way. Okay. So this is one type of rebar. Another type of rebar is TMT rebars or QST rebars. These are the type of rebars which we are actually using in our site. So this type of QST rebar, these are the rebars. If we talk about how its microstructure will, why it is called TMT rebar is, it is tempered martensite rebar, thermomechanically treated tempered martensite rebar. Or other thing is quenched as self-tempered rebars, they are called as. So what is the step is happening is, while milling, we are forming it, and then we are suddenly heating, when it is heated, it is suddenly cooled down. So what will happen when it is suddenly cooled down? So outer layer will be cooled down. However, the inner part of our rebar will be still hot. So what will happen? This inner side will have a different type of microstructure as compared to the outer layer. So that's why it is called as tempered martensite rebar. Oh, sorry, outer surface will be of tempered martensite type and inner will be ferrite pearlite. So this difference in structure, microstructure is mainly due to the heating procedure. When it is suddenly cooled down, outer will be cooled down and inner will be still be hot, and it will cool down with time. So that is how TMT rebars are formed. So how to check if a TMT rebar is of good quality or poor quality? So there is a test called TM ring test. In that test, what we are doing, we will cut a cross section of our rebar, immerse it in epoxy, and then clean the surface fully. And then what we are doing, we are using this normal setup, or you can see visually also. You will just pour 5% NPTEL solution over the surface, and what will happen with NPTEL solution? It will etch the surface. Some etching will happen. So if etching is happening, you can clearly see a ring forming inside your rebar. So this dark gray part is your temper martensite and light gray part is your ferrite pearlite. So how to tell if your rebar is of good quality or not? If a ring is forming properly, then we are telling it is a good type of rebar. If it is not forming properly, then it is a poor quality of rebar. Okay. So that is what you might have studied in week 7. If you have any doubt, you can ask me. Otherwise, we will go to the question and answer session. Okay, if there are no doubts, then we will see some questions. Okay, question number 1. Typically, the iron ore used in the production of iron is hematite, magnetite, elite, limonite. Any idea? You can guess the option also if you want. So in India, normally we are getting hematite type of iron ore, that is, which is used in the production of iron. Okay, so second question is, reduction of iron ore happens inside a blast furnace at, so it is visible from the figure. You can tell at what temperature reduction of iron ore is happening. You can send in chat box also if you want. T, okay, 700 degrees Celsius, correct. So from here you can see at 700 degrees Celsius, iron ore, which is basically iron oxide, is reducing to normal iron in presence of carbon monoxide. Okay, good. Third question, as carbon content in the iron increases, strength increases and brittleness decreases. Strength decreases and brittleness increases. Strength and brittleness decreases or strength and brittleness increases. Any guesses? So we have seen the diagram that is only telling about us the strength. So in that diagram, strength was increasing or decreasing? We talked about the normal iron, then we talked about mild steel, then high carbon increasing. Correct. So strength was decreasing. However, if you increase the carbon content, your normal, from this diagram, if you see, if your carbon percentage is increasing, what is happening? Your normal strength is increasing. However, your ductility is decreasing. As you have seen this cold deformed rebar also now, your strength was increasing and your ductility was decreasing. So same case is happening here. If you increase your carbon percentage, your microstructure will change from ferrite to pearlite, and your cement, in that case, what will happen? Your brittleness will increase. So answer is D. Strength and brittleness will increase as your ductility is decreasing, so brittleness will increase. Next question. Ductile iron is more ductile than cast iron because of the presence of magnesium, rubber, flaky graphite, or spherical graphite. So it is clear from this picture. If you see, this is your ductile cast iron, this is your gray cast iron. What is the main difference between this microstructure is present of this spherical material. So this is black lead, which is also called as graphite. So why it is called as ductile iron? Because of the presence of spherical graphite. So the next question is, choose the correct statement. Bond strength of plain rebars is less than bond strength of ribbed rebars. Bond strength of plain rebars is more than bond strength of ribbed rebars, or the bond strength of plain rebars is equal to the bond strength of ribbed rebars. So this part we already discussed. You can A, correct answer. So this ribs will provide a good bonding between rebars and concrete. So that's why bond strength of plain rebars will be less than bond strength of ribbed rebars. Next question is, molten iron is lighter than molten slag. True or false? Any idea? From the figure, you can see if it is lighter or heavier. I think it's clear. So if you can see here, this is a complete molten material. Molten slag will be always above molten iron. That means it is lighter in weight as compared to the molten iron. So molten iron is actually heavier than molten slag. So the statement is false. Okay. So the next question is, the manufacturing of cast iron is a more controlled process than that of pig iron. True or false? So this is a pig iron, how pig iron is made, and this is how cast iron is made. So which, from the figure, how, what can you say, which look more controlled? Guesses? So if you can see from this figure, what is happening is just steps are formed. On that, you are just pouring your molten metal. However, in case of cast iron, you are preparing a mold and filling it with sand and then pouring the molten metal into it. So from there, you can see that cast iron is more controlled process as compared to pig iron. Oh, this is A actually. Okay, so the next question is iron is at a higher energy state than iron oxide. True or false? Yes. So we are telling that we are forcefully converting iron oxide, ferrous oxide to iron, right, in blast furnace lab. Convert to have this conversion, we are using blast furnace. So sorry for my writing. However, when we are telling our iron is oxidizing into iron oxide, that is happening naturally, right? In presence of oxygen or moisture. If this process is happening naturally, that means which one is more stable state? Iron, iron, pure iron or iron? So what we are saying is any material in nature actually tends to stay in their lower energy state. So if our iron tends to stay in its iron form or in oxide form, that means iron oxide is have a lower energy state as compared to iron. So iron is at high energy state, and oxide is a true statement. Okay. Okay, so we talk about three type of iron: pig iron, cast iron, and wrought iron. In which type of iron slag was present? So if you remember, in wrought iron, we told that it have less than 1% of carbon content and slag plus slag. In these two type of iron, what was present? Sorry, I didn't put the pig iron image. In pig iron means that is a pure iron, just with natural impurities. And in cast iron, we are adding this some graphites are added, right? And slag was present in wrought iron. So the next question is cold twisting of steel is done at a temperature below the recrystallization temperature, above the recrystallization temperature, or at the recrystallization temperature. So what we are telling about cold twisting is cold twisting we usually do it at a lower temperature as compared to the normal heating up procedure. So cold twisting of steel is done at a temperature below the recrystallization temperature. Okay. Next question is in QST rebar, ductility is provided by the tempered martensite resin, ferrite pearlite, austenite, martensite. So first thing, if you see from here, you have only two part, tempered martensite and ferrite pearlite. So which part will provide ductility and which part will provide strength? Normally, we are telling since this part is heated rapidly, the tempered martensite, it will provide strength, and this inside part it is more flexible as compared to the part is more of hard. It provides hardness, or we can say strength. And the inner part, which is cooled down slowly, it will provide the ductility or flexibility to our structure, to our rebar. So which part is providing ductility? It is ferrite pearlite. Okay. So next question is, presence of residual stresses in a rebar can dash the corrosion resistance. Decrease the corrosion resistance, increase or not change. Whenever there is some stress present into our rebar, what will happen? The corrosion resistance of our rebar will A. I hope you have answer for this question will be A. Correct. It will decrease. Why it will decrease? Because if some stresses are present, that area wherever stress is present, that will have a different type of atmosphere or environment as compared to the other area. So there is a galvanic cell forming, and the stresses will create a what you say more vulnerable area for corrosion to take place. So the next question is, in QST bar manufacturing, temperature of core is different than that of surface. True or false? So this we have been reading since start of the lecture. We are telling the temperature of tempered martensite and ferrite pearlite during manufacturing is always different, right? Answer is A. So question number 14th is solution used in TM ring test is. So we are making some solution. We are pouring it over the rebar. It is etching our surface. What is that solution called? Niter solution. It is formed with, it is 10%, 15%, 5% or 20%. I forgot to write that. Anybody remember? C. Correct. So we are making niter solution with 5%. It is a 5% niter solution. So the next question is related to the same thing. What exactly is niter solution? It is nitric acid plus ethanol, nitric acid plus phenolphthalein, nitric acid plus carbonic acid, or nitric acid plus sulfuric acid. Any idea? So niter solution is actually 5% of nitric acid in ethanol, 95% of ethanol. So that is called as nitrile acid. Okay. So 16th question is, the additional ingredients in the manufacturing of corrosion resistant steel rebars are chromium, copper and phosphorus, magnesium, carbon as phosphorus, chromium, titanium, and sulfur. So in corrosion resistance rebar, what we are using? It is an alloy of what? Chromium, copper, phosphorus, magnesium, carbon, phosphorus, chromium, titanium, sulfur. So in corrosion resistant steel bar, we are having alloy formation of chromium, copper, and phosphorus. Okay. So next question is type of corrosion when cracks develop due to the improper outer and inside layer of TM rebar is called as. So this figure you might have seen in the lecture. So if there is a no proper TM ring forming, when we are bending a rebar, there is a crack forming and there is a chance of corrosion at this point. What is the type of corrosion called as? So it is a type of crevice corrosion. Why crevice corrosion is? If you can see at this point, there is a formation of crevice where there is a if you see here, there is a formation of crevice. Crevice means a type of gap. A gap is formed in between rebars because of this cracks. A very small gap where where oxygen can't reach, and then what will happen? There is a difference change in environment, and it will cause corrosion. That is a type of crevice corrosion. Okay, so the next question is match the following. We have three type of iron: cast iron, ductile iron, and wrought iron. So what are the different microstructure? Globular, grain, flaky, graphite. So for cast iron, what kind of structure we had? So first thing we can differentiate here itself is that wrought iron doesn't have graphite. So wrought iron and wrought iron have grain structure. We have grain bondage and grain. So C is second. Now between cast iron and ductile iron, which one have globular and which one have flaky structure? Cast iron have any idea? C, correct. If you remember clearly, this is the type of structure. In cast iron, we have flaky graphites, and in ductile iron, we have spherical or globular graphite present. And in wrought iron, we don't have graphite. What we have instead of graphite, we have presence of slag and less than 1% of carbon, and it will have green structure. So the correct answer will be A3, B1, and C2. So the next question is type of corrosion when two dissimilar metals are in contact, developing a battery between them is known as. I'll give you an image of this. So if we have two different type of metals, one this is a different metal and the screw is of different metal. However, only screw is getting corroded, not the complete structure. What is happening is a battery or a cell is forming between these two metals, and this type of corrosion is actually called as galvanic corrosion because a galvanic cell is forming between two different type of metals. So the next question is in construction, cast iron is commonly used for which of the following application? For the structure beams, for the concrete bars, for drainage pipes or manhole covers, or for the high tensile cables? Any idea? So if you see, if you remember cast iron we talked about, it have a low strength as compared to a high carbon rebars. So it cannot be used for the structures purposes. It cannot be used for the structure beam or for the concrete beam. Other thing, again, if you talk about cables, if we are telling about high tensile cable. However, the tensile strength of our cast iron is low as compared to a high carbon rebars or a high density rebars. So in structures, we can only use it as the for the drainage pipe and manhole covers. Okay. So this is the last question. CTD bars are generally manufactured from which type of steel? Mild steel, high carbon steel, high strength deformed steel, or stainless steel? Any idea? So CTD bars are cold deformed bars. They are actually made from the high strength deformed steel. Normally, how we are making our like 415 or 550 rebars from the same high strength deformed bars, we are making cold deformed rebars. Okay, so that's all for week 7. If you guys have any doubt, you can ask me now, or you can put in chat box also. I will upload the lecture 6 by today. So this one also. So if there are no doubts, then we will close the class for today. Thank you.